exponent x plus 1 plus 3 exponent 2 minus x, and this expression is equal to log 7 plus log 4 out of log 2 to the base 2. Okay, so you can see that over here, log 2 to the base 2 will give us 1. Okay, so this one will give us 1, which will mean that we have log 4 standing alone, right? So the denominator will give us 1. So over here, this is what we are going to do. We have a bracket here, meaning this thing sitting here is standing as a whole. Okay, you can't just put in the bracket, you know. You have to leave it the way it is because standing as a whole. We are going to have log of this equals, now that this one is 1, now you can see here we have log 7 plus log 4, right? And this here, the law of logarithms comes in, and therefore it's going to give us log 7 times 4. Okay, so when they are adding, you take one of the log and multiply the values. Okay, now at this point, this is going to give us log 28. Okay, so at this point, what we do over here is we take antilog of both sides. We take antilog of both sides. So when you take antilog of both sides, this is going to leave us with so when you take antilog of both sides, you are going to leave with log x, log to the exponent of x plus 1, as we have it here, plus 3 exponent 2 minus x equals 28. Now we have reduced everything to indices. Okay. Now, so what we do over here is that this expression over here, 3 exponent x plus 1, we can split it. We can split it into 2. Because we know that 3 exponent x times 3 exponent 1 will give us 3 exponent x plus 1. I hope you can see that. So what the law of indices says, the law of indices says that 3 exponent x times 3 exponent 1, here the bases are the same. So when the bases are the same, take one of the base, then we add the exponent. Okay, then we add the exponent. So that's what we have here. Now we can also split this one in the same manner. So we have 3 exponent 2, but this time right is minus. And when it is minus, then it means our sign is division instead of multiplication because of the minus sign. So 3 exponent x, okay, equals 28. Good. Now we can put them together, we can simplify and put them together. 3 exponent 1 give us 3. So we have 3 multiplying 3 exponent x. Okay, so 3 times this will give us that. Plus, this side, 3 exponent 2 is going to give us 9. Okay, so we are going to have 9 out of 3 exponent x. And this is going to give us 28. Okay. So over here, you can see a fraction over here. We can multiply through by the denominator, which is 3 exponent x. Okay, so here we are going to have 3 exponent x times 3 exponent x, okay, plus 9 out of, okay, so we are multiplying through by 3 exponent x, as you can see right there. Then this one should be equal to 28 times 3 exponent x. So multiplying through by 3 exponent x. And what are we going to get over here? So you can see we have 3 exponent x, 3 exponent x. So we can put them together. We have 3 exponent x all squared because they are 2. Plus this one, we cancel this one off. 11 us with 9. And this one should be equal to 28 times 3 exponent x, which is 28 3 exponent x. So that's what we are having. You have 3 exponent x over here, 3 exponent x over here. Now, what we have to do is, we need to represent 3 exponent x with any variable for our choice. Okay? Represent 3 exponent x with any variable of our choice. Let y equal 3 exponent x, as we stated earlier. In this case, we are going to replace them. Wherever we see 3 exponent x, we put y. So we are going to have 3 plus 9 equals 28 y. 28y, okay? So over here, when we expand the bracket and multiply, we're going to have 3y squared plus 9, and this is going to give us 28y. You see we are getting a quadratic equation. We can rearrange them nicely to see our quadratic equation nicely. So over here we have 3y squared. Then we bring our 28y to join them, minus 28y plus 9, and this one equals 0. Now we will see that we have a quadratic equation over here. We can solve quadratic equation by factorization, quadratic formula. If any of the formulas, you can use them. So over here, let's look at factorization. 3 times 9 gives us 27. Okay? 3 times 9, 27. So we are looking for two numbers. When you multiply, you get positive 27. When you add, you get minus 28. And this one is going to be minus 1, minus 27. Yeah. So in this case, we are going to have 3y squared. So our two factors are minus 1 and minus 27. So in place of this minus 28y, we put minus y minus 27y. So we have minus y minus 27y. And we have plus 9 equals 0. Right? So we put this one in bracket nicely. And factor common turns out. So over here we have 3y squared minus y. There's 3 here, there's no 3 here. So we can factor 3 out. Y squared, we have 2 of the y's. That's why we have y squared. So 2 of them are here, and we have 1. So we can bring 1 of the y's out. Okay. So we are going to have y out. Okay. Then here we have taken 1 y out, so we are left with 3y. Here the y has been moved out, so we have 1. Okay. And this side, common factors, there's y here, there's no y here. Okay, so we can factor y out. Now 27 is here, there's 9 here. 9 is a factor of 27, therefore we can bring 9 out. Okay, so we are going to have minus 9 out. Here, when we take 9 out, we are left with 3y. Then because of this negative sign outside, to change the inside one, then the positive sign to negative, to have our y. And this one should be equal to 0, right? So in this case, we take one of the brackets, which is 3y minus 1. Then those at the back, we put them in one bracket. And this is equal to 0. So here we can see that our y is either this one is equal to 0 or this one is equal to 0. So if this one is equal to 0, you make y the subject and you are getting 1 out of 3. So it means our y over here is going to be 1 out of 3. Or over here we are going to get 9. But remember that y is not on its own. Y is representing what we have here, which is 3 exponent x. So in place of y, let's fix or let's substitute our y to 3 exponent x. Okay? So when we substitute, so over here we are going to have 3 exponent x equals 1.3 or 3 exponent x equals 9. So in this case, if 3 exponent x is equals 1.3, so it means automatically our x is equals to negative 1, right? Well, this one's, when you reciprocate this, you are going to get over here, you are going to get 3 exponent x to be equals to 3 exponent negative 1, right? And this is going to be x is equals to negative 1. Then we take the second part, you have 3 exponent x to be equals to 9. Okay? So 3 exponent x equals 3 exponent 2. The bases are now the same, and therefore our x is equals to 2. So in this case, the values of x from the equation are x is equals to negative 1 or x is equals to 2. And this is the solution for the problem.